Welcome Chemistry 1A. In this recording, I am going to go over the theory of, the experimentation of, and the calculations related to the stoichiometry of a precipitation reaction. I'm going to toggle back and forth between some documents that I'm going to show on screen, so please bear with me as some of it will go a little bit slow. So I'm going to share screens now. There we go. And we see what I have. Let me get it centered. There we go. What we see is what I have prepared as the way I might prepare a laboratory notebook associated with this experiment. So of course, there's the date that needs to go on the page, the title of the experiment, stoichiometry of a precipitation reaction, the objective. I took some liberties with it, determination of the percent yield of a double displacement reaction using gravimetric methods, right? I might have said precipitation reaction, it really means the same thing. Using gravimetric method, that means we're weighing things out instead of, say, spectrophotometric methods or other means of analyzing things. I have written the reaction for the experiment. I want to comment on that reaction a little bit. It is a precipitation reaction. Everything on the left is soluble. The calcium carbonate is the precipitate, and the sodium chloride remains as spectator ions, and of course a little bit of water is given off. Note that this reaction involves the combination of two items, and depending on the circumstances under which we perform the experiment, it could be the case that one or the other of them is the limiting reagent. We are setting this up so that the calcium chloride is the limiting reagent, and that is a slight deviation from the way the HOL lab writes it out. We'll see in a bit the HOL lab wants you to use the precisely equivalent amounts of each of the two reacting materials. We're going to see later as I do my calculations that I'm asking you for an ever so slight excess of sodium carbonate. And that will become apparent later on when we do the calculations. There is, of course, a table of reagents. There's not a whole lot going on, just a couple of reagents that I have listed. They are both solids. The procedure, if you were doing truly novel experimentation that had never been done before, you would, of course, provide the complete description of the procedure. There's no such need here, right? We know where the procedure is, so I have referenced the web page and the date upon which I have accessed that web page. That happens to be November 12th, and that is sufficient. Sometimes you can make a reference to a procedure, and then if there's ever so slight modifications, note those modifications. But again, for us, there's no need to. Now I've left a space for observations, but since I have not done the experiment yet, there's no observations to write down, but you should complete anything that you observe as you perform the experiment. I have set up a data table. This one's pretty straightforward. There's not a whole lot of information we're going to be collecting, but I have, of course, read through the procedure so that I have a basic idea of what to understand and expect. And that is some calcium chloride that we start with. We add sodium carbonate. I want to know the mass there. I've got a space for the mass of the clean and dry, emphasis on dry, filter paper. And then the mass of the filter paper that contains calcium carbonate, the final product that we're doing. And again, emphasis on the fact that it needs to be dry. Now, I haven't done any calculations yet because I don't have any data, but that will be done later after I demonstrate the experiment. Okay, I'm going to stop sharing now and proceed on to the experiment. So I'm back over here. And again, we've got a couple of beakers. We have a weighing boat for the material we need. We've got calcium chloride, sodium carbonate that you came with, a spatula to move it out with. Of course, safety glasses, I'll put those on now. The 25 milliliter graduated cylinder and one piece of filter paper. I find it curious that of all of the things that HOL tried to save money on, it was by not giving you 2 pieces of filter paper. So you only have, I think, 1, which means that you don't have an opportunity to do this experiment twice. And maybe that's just as well, because I don't think they've given you enough chemicals to do it twice. But please, don't get this torn, or you simply won't be able to do the experiment. Of course, I've got my purified water, which we'll use as distilled water. And when I need to, I will get some paper towels and such. So that's all of the material we need. Of course, I have my scale to weigh materials out with. And now let me proceed. I hope I am doing this in exactly the same order as in the procedure. But if not, none of the changes that I might make ever so slight really have no bearing on how things work out. So one of the first things that's asked for is to get 25 milliliters of water. The volume is not critical, right? It is only there to get everything dissolved. So if it's 24 or 26 or 23 or 27, it really does not make any difference at all, right? So one of the keys to being successful in the laboratory is knowing when to pay real close attention to something and when something really just is not that important. So now I've got my scale, and again, I won't be able to show this to you because I dumped the materials out, but I've got that on there, and I gotta make certain I get the right one. So I've got my calcium chloride dihydrate. The procedure calls for 1.5 grams. But if you don't get exactly that amount, that will be fine, because all of the calculations are going to be based on what you actually use. So I'm going to pour this gently in there. And I know you can't see that. You're just going to have to trust me on some of this. There we go. Now, the measurement that I see is 1.47 grams. And I see there's one other thing that I didn't have. Excuse me while I reach back here and get myself a Sharpie. Particularly helpful in any laboratory setting. It's one of the few things that you can use to write on glass. So I want to write on here that this is my calcium chloride. All right, so that's my calcium chloride. If you can't read that, don't worry about it. Just know that I've written calcium chloride on there. Now, this goes in there. Use some caution to make certain that everything that ends up in here, note that I'm kind of holding it in there and just tapping on it a little bit. There we go. Now you can see maybe there's a little bit of residual in there. So I'm gonna just get a little bit of water and wash that down in there. And I say, well, that's now giving it more than 25 milliliters of water. Well, it is, but as I said, that's not particularly relevant. Now, so at this one, I've got 1.47 grams of calcium chloride, and we'll get that dissolving. Right, we're just going to get that dissolving. And while we do that, I'm going to share screens again and go to a calculation, because we want to use the remaining material, sodium carbonate, such that the calcium chloride remains the limiting reagent. Well, we have to know how much sodium carbonate is necessary based on 1.47 grams. Now, I want to point out that you, of course, are going to have a value or an amount different than 1.47 grams. And here we go. You are now seeing the calculations based on the amount that I actually used. So I actually used 1.47 grams. This is a simple conversion, of course, to moles of calcium chloride. Here's the 1-to-1 ratio of sodium carbonate to calcium chloride in the balanced reaction, and the formula weight of sodium carbonate. So this tells me that if I wanted the exact amount of sodium carbonate to react, I would want 1.06 grams. Well, as I said, I want this set up so that the calcium chloride dihydrate is the limiting reagent. So when you weigh out the sodium carbonate, in my example, it's 1.06 grams. Whatever you get, it's of course going to be close to this value. make certain that is the minimum. And if it's, a couple of hundredths more, I put 0 to 0.05 grams more, that's perfectly acceptable. So I'm going to stop sharing, go back to my experiment. There we go. And proceed. And by the way, you see this solution is getting clearer and clearer, which is an indication, of course, that the calcium chloride is completely dissolving. Now, I don't know if you can see in here. It's a little bit difficult, perhaps, but right down, yeah, it is difficult. But I guess on my left-hand side, there's a little bit of calcium chloride sitting down there on the bottom. Sometimes it'll get a little bit solid. So I'm gonna get down in there and you can't see it. I'm wanting to make certain this is completely dissolved, because of course, if it's not completely dissolved, it will not react completely. So there we go. Now, okay. And I've got a little bit of liquid hanging up here, and that liquid has some calcium chloride on it, or in it, excuse me. And I want to make certain that I rinse that off and get everything back into the solution so that this has nothing but distilled water on it. Okay, so that's set up. Now, we said I needed 1.06 grams of sodium carbonate, and I am going to add this on here. You, of course, have the spatula. If you have the exact same container that I do, you can see I'm just kind of twirling it back and forth. Remember, it's always best to go slow so that you add a little bit at a time, because trying to put stuff back in the bottle is, of course, going to be difficult. So again, I know you can't see the scale. You just kind of take my word. There we go. Oops, a little bit too much. 1.09 grams, right? But that's more than the 1.06 grams that we know is the minimum. Again, a little bit of caution. The sodium carbonate is mildly caustic, right? If you get some on your skin, it's not a big deal. Now, again, what you can see is I have some sodium carbonate that's hung up on there. So I'm gonna just rinse it off with a milliliter or two to make certain that I get everything that I weighed out in there. There we go. Save that for possible future use. Now, again, you can see, of course, that I put that solid in there and it's a bit cloudy, and of course it will create a bit of a solid clumpy mixture on the bottom. So we need to stir that up so that it is completely dissolved, and just gently break up a little bit of the little clumps that form in there. Okay, so getting that dissolved, and a bit of downtime here. I'm not going to pause the video. It's only going to take me a minute or two of stirring to get this set up. So while I'm doing this, again, we recall when we were doing writing reactions, one of our solubility rules told us that sodium salts were generally soluble, and they are. But there's a difference between something being soluble and dissolving quickly. Just because something is soluble does not mean that it will dissolve immediately. And we can see that sodium carbonate is taking a moment or so to get dissolved. The cloudiness is going away. And again, you can't see it, but you will on yours. At this point, all of the solid particles have pretty much disappeared. And maybe you can see in the video that it is getting more and more clear as we go along. And of course, once it gets completely clear, that is our indication, of course, that everything has dissolved. Still a couple of granules down in there. We want to wait until this is just as clear as that one. Now again, I've got some sodium carbonate that's in that solution. And since everything is based on mass measurements, I want to make certain that I get everything into the beaker that I started with. Okay, start over here. And again, I should have done that. Let me do it now. This is, of course, the sodium carbonate. Now, frankly, I don't recall in the procedure which one it says to add to the other. I can't see that it makes any difference whatsoever. So let me get my scale out of the way. Close that up. Bring this in a little bit closer so you can get a good look at that. Of course, you'll get a good look when you do it yourself. So I'm going to have my sodium carbonate pouring into my calcium chloride. And as the procedure says, you immediately see a precipitate. And that is, of course, the precipitate that we want to collect. That precipitate is calcium carbonate. Let's take just a little bit, pour it in there to make certain that we get all of the sodium carbonate in there. Okay, you don't want to use too much water, because the more water that you have, the more that you have to filter away. So again, just be a little bit cautious with regard to how much water you use to transfer, because again, eventually you got to get rid of it all. Okay, so we've got that. It's best to, of course, stir that up a little bit to make certain that the reaction has had an opportunity to occur. Some reactions take hours or days or weeks or months. All right, when I was in graduate school, I had reactions that literally took months to proceed to completion. And so, you know, having this reaction over in a matter of seconds is really rather convenient. Again, gonna rinse that off carefully, not to use too much liquid. Okay, so at this point, the white material that we have in here is the calcium carbonate that we want to determine the mass of. We can't do that, of course, while it's sitting in the solution. So I'm going to set that aside and walk through the procedure for the filter paper. The HOL procedure, excuse me, has some good pictures, but it doesn't point out some of the challenges here. So one, mine came half folded, perhaps yours did as well. Give it a nice good crease halfway, and then fold it in half again. So we've got it now quartered. Give it a nice good crease, and then fold it in half one more time. All right. And I realized, of course, I had my funnel just out of view, because we do need, of course, need our funnel. Now, at this point, we've got the paper and the funnel, and we want to put that in there. Now, you can see that's not going to work very well, right? We can't start with that dry. Some of these will kind of bounce out on you a little bit, or just everybody's is a little bit different. But we need to prep the filter paper here. So I've got it more or less set up. And this next part, you know, I'm going to demonstrate, but you're just going to have to kind of figure it out yourself a little bit as you go along. So again, I'm kind of taking it apart and trying to get it, and maybe if you can see, I'm grabbing one piece and folding it in so that I've got it like that. So I've just kind of folded one in, and let's see if I can get that in there. I might have to fold it again. This is one of the challenges with these HOL kits, is while they certainly provided us the specific stuff that we needed, it is not always the best of sizes. There we go. Again, I don't know if you can tell, but I've just kind of folded it up a little bit more. So do all of this while it's dry, because once you start the experiment to filter things, you're really not going to have the ability to filter it very well. So there we go. So I've got that so that it fit in there fairly well. Now let's see if I leave it. Yeah, this is what, so if you leave it, it's going to come back out again. So I'm going to put that in there. Again, I'm going to get that, maybe not that one. Let me come back over here. This is my beaker that I've now used. I don't need it. I'm going to get that set up in there. And to keep this down in here, and I'm kind of holding it in there, and I'm going to get it wet. Now, shame on me, I did measure the mass of this filter paper. So I'm going to pause here and make a real important point of that. I did measure the mass of this filter paper before I did this. I should have shown you that, my apologies, but you need to measure the mass of the filter paper before you start, right? Pardon me, let me look up the value that I had on there. The mass of my filter paper, the mass of my dry filter paper was 1.43 grams. 1.43 grams was the mass of my filter paper. Okay, so again, I put a little bit of water on there and that helps it stick to the sides. Now I'm set to go. Now I'm going to transfer this. Now, well, let me do it right now. What I'm going to do is I'm going to stir this up to get the calcium carbonate suspended, not dissolved, but suspended, and then pour it in. Be careful not to pour so much. Don't pour it all at the same time. It'll overfill, and of course, that will immediately ruin any possibility of getting good results. So, that's stirred and suspended, and pour it in there. And again, what you can't see is how high I'm going this, but I'm going about 2/3 of the way up. So there we go. I'm going to set that aside. And what you can see, of course, is it dripping through reasonably quickly. So no point in trying to rush this at this point. Again, if you pour too much in, it's going to spill over the sides, not go through the filter paper, and we will end up not collecting all of the calcium carbonate. And that, of course, is a major problem. Okay, so the dripping continues. So again, you can see at this point why the initial 25 milliliter volumes are not important. We're just going to end up getting rid of it all anyway. And in addition, the more water you use, the longer you have to wait. And while waiting for good results is, of course, noble, waiting for no reason has no nobility at all. Okay, so it's continuing. I'm going to pour a little bit more in there. Again, filling it about 2/3 or 3/4 of the way up the side. And the dripping continues. Mm-hmm. This is actually fairly fast. There are actually different grades of filter paper in terms of how thick and how good a job they do of filtering. Some of them you might get a drop per minute or through to pass through the filter paper. This is certainly much faster than that. So again, you can't see what's in there, but it's getting down. And now, again, you perhaps can see that this is a little bit cloudy. That's because there's some calcium carbonate in there and we want to get that out. I'm going to rinse off my spatula and, there we go, a little bit more. And stir that up. In a research lab or an industrial lab, there would be different kinds of glassware that makes this transfer far more quantitative. Quantitative is just a way of saying it makes it far more complete. But under these circumstances, we really get enough to filter through. You can't see the drops coming through because the bottom of the funnel is now immersed, but trust me, it is moving through. Again, I'll lift this up and of course you can see the drips continuing. So that's going to continue. Now, while that's getting set up, I'm gonna get myself a paper towel. I've got my paper towel. I'm gonna get myself a small plate. So you can see I've got myself a small plate. I recommend that you get a piece of glassware or perhaps something that you don't actually, you know what? Never mind that. It would really be bad form for me to suggest to you that you use kitchen glassware in a chemistry lab, even if the risk is tiny. So I'm going to use one of these cups that we've seen before and just a piece of just a paper towel or some such thing. It really doesn't make too much difference. I'm going to set that aside. Still a few drips. Now, again, what you can't see is I'm almost done. There's perhaps only a couple more milliliters left. Now, while we're doing this, I'll ask the question, what's in here? What ions are in here? Well, we started with calcium chloride and sodium carbonate. The calcium carbonate's in here, so that means the spectator ions should be down here in this solution, sodium chloride. Now we set this up so that the masses of each one are in pretty near stoichiometric equivalence, meaning they're the precise amount. So this, in theory anyway, this should be nothing but sodium chloride. And in fact, I'm sure it's really pretty close. So when we're done, we're of course just going to rinse this down the drain. Now, I'm going to sit this back down. And again, of course, I can't tip this up for you to see it, but it's effectively fully filtered. There's just maybe a little bit of moisture in there. And I don't know if this step is in the HOL procedure, but I'm going to give it to you now. Since this filter paper is all wet, inside the water that is in this filter paper are sodium chloride. Sodium is sodium chloride, because anywhere there's water, there's sodium chloride. And we don't want those in there. So I'm going to give just a little bit of, we say, just washing the precipitate is just another way of saying, of washing out the sodium chloride that might be in there. Okay. So now that I've added just a little bit more, we can see, there we go. It's back to dripping. So I'm going to leave that sit there for a moment. Okay. Now, this of course will be posted in Canvas with regard to what I am asking you to submit to me. One of the things that I want submitted is a picture of the filtrate at this point, showing the precipitate on the inside. So that's the first thing, the first picture I want. A top-down picture of this funnel with the solid precipitate in it. The second, I can't show you right now, but the second is this filter paper after it's completely dried. Okay. Still just a tiny bit left in there. No sense to rush it now. Just another drop or so. If you can, I'd recommend you get to this point, clean up everything else, clean up, make your notes in your notebook and let this filter for as long as possible. The procedure, I think, says 15 minutes. That's certainly enough. Okay. So again, one of the things I want to warn against is do not try to move anything around in here. If you do so, you will almost certainly tear the filter paper. If you tear the filter paper, of course, the calcium carbonate will go right through down into here, which is where we don't want it. So again, I've been very careful not to do that. So we're going to get any of the last little bits out. And now I'm going to get this up here. Let me set this aside. And take that out. And I'm going to lay that down very carefully right there. Set that aside. We don't need it. Now, this is what I need you to set aside to dry. right? So maybe this little aluminum container wasn't quite the right thing. Let's see if we have do we have, excuse me, while I look in our own kit. You know, anything will do. I'm going to use a beaker. You can use anything that you want to set that aside. Now, the procedure says to put it in a warm window. Well, at least in the Northern Hemisphere, we're approaching winter at this time. But I've got that set aside, and I'm just going to set it someplace where it'll be warm. Do not try to dry it off in an oven or a microwave or anything that involves direct heat. The likely thing that would happen is you would burn or char the filter paper or otherwise lose material and of course, get catastrophically bad results. Okay, there we have most of the procedure. Now, let me get my zoom a little bit closer. Very good. The next part that I'm going to go over is the calculations. Now, obviously, I'm just continuing this Zoom, and so I'm going to pretend, and you're going to believe me, that I have come back a day later to weigh that material again. Now, clearly, it's still sitting wet over my windowsill, but we're going to pretend that it's now a day later, and I have dried and reweighed the filter paper. I want to show you what the calculations look like for this experiment. So I'm going to share my screen. And where are we? Calculations, I've already shown you these before. So here's my mass of the calcium carbonate and filter paper, the value that I just said that we'll presume that I obtained, the mass of the calcium carbonate, the theoretical yield calculations. Theoretically, I should get 1.001 grams of calcium carbonate. In actuality, I obtained 0.88 grams. So the percent yield is 88%. And then I'll let you consider where the uncollected calcium carbonate went. There we go. That is the end of the recording. I will close this up in a minute. As always, reach out to me with questions, and we'll see you in class.